Hello? Hello, Kavitha? Hello? Hello, Kavitha Sharma? Hello? You joined there? Visalini? Kavitha, you joined. Thank you, Kavitha. I can't hear anyone. What happened? Visalini, you have to unmute yourself. Kavitha, you have to unmute yourself. कविता तुमने अपने आप को अनम्यूट नहीं किया
Sorry. Yes, now it's unmuted, ma'am. Am I audible?
हाँ अभी ठीक है विशालिनी even you have to unmute Visalini it's not
yes,
unmuted
now. Yes, ma'am. Now.
Welcome Kavitha.
Thank
To see you.
Thank you. Thank you, ma'am.
So my principal sir told I will join at the end of your session. Just he want to talk to you. Okay.
Sure.
So thanks for so fast you came back. You thought the talk is by 4 o'clock.
Yeah, yes, ma'am. I thought it is on at a 4 o'clock. I was just having my lunch actually.
That's why you came so suddenly. Thanks a lot. Okay, Visalini, we will start officially.
Okay, ma'am. Okay, ma'am. Good afternoon to one and all present here. On behalf of the President of Chairman Education Society and Chairman of the Oxford Education Institute, Management, Principal, Dean, HOD, staff, and student of the Oxford College of Engineering. I, Vishalini, extend you all warm welcome to the seventh day of second week FDP on advancement in quantum computing and sensor technology for Vikshit Bharat at 2047, organized by Department of ISC, CSC, ECE, and EEE. On this occasion, it is my great pleasure and honor to welcome our distinguished speaker, Dr. Kavitha Sharma ma'am, for this event. Dr. Kavitha ma'am is a research professional and research professionals in IIT Delhi. Her research field are bio-optic, fiber optic sensor, plasmoid, biosensor, plasma physics, surface plasmon, lossy mode, resonance, nanostructure synthesis, adulterant detection, sensor technology, atmospheric turbulence. Now, over to you, ma'am.
Thank you. Thank you so much for introducing me. Okay, let me share my screen.
Yes.
Is it visible to you, ma'am?
No. Now it is there.
Okay.
You have to make it to the presentation mode.
I made it. Yes, I made it already, ma'am.
Yes.
The presentation mode.
Okay, so now you can.
Is it visible now? Clearly?
Yeah. Okay. And you are audible also.
Okay, thank you, ma'am. Thank you so much. First of all,
little louder. Your sound is little less.
Oh, I'm sorry. Now it is audible, I think.
Audible. Visalini, for you, it is audible?
Yes, ma'am.
Visalini?
Yes, ma'am.
Audible?
Yes,
okay.
ma'am.
Okay. So first of all, thank you so much for inviting me for here for the talk. My name is Kavitha and I'm working here in our Science Department, IIT Delhi, as a research professional. Today's talk will be about implementation of biosynthesized gold nanoparticles for skimming selective DEA sensing with the help of optical fiber sensors.
Just a minute, Kavita. Just a minute.
Yes,
Visalini,
yes.
just a minute. Visalini. Hello,
Yes, ma'am.
Visalini.
Yes, ma'am.
First page you
Started
take
recording.
the print screen.
Yes, ma'am. I have taken.
First page. Okay.
Yes, ma'am.
Okay, now you can start, Kavita.
Okay, ma'am. Thank you. So these are the outlines for today's talk. First of all, we will discuss about the motivation for this sensing, this study, why we have done this study, then the synthesis and characterization of biosynthesized gold nanoparticles, and then experimental setup that we have used during the experiments, and then result and discussion, then the sensing mechanism for making the sensor selective towards amine only, followed by the conclusion. So we'll start with the motivation, which comes from the literature that we will get to know that DEA, diethanol amine, is a chemical which is used in cosmetics, skincare products, and pharmaceuticals as a foaming and emulsifying agent, corrosion inhibitor, and lubricant. It is most widely used, and it is also used in crude oil and oil refineries as a for the process of aminos. But due to some human fault or some technical faults, some amine left behind in the process water, which is further processed or transferred to the wastewater treatment plants. But the workers working in these industries are continuously in the contact of these chemicals, so it may harm them. So these are the allowed range of the DEA in vapor and liquid form. According to European Union cosmetic regulation, it is allowed up to 5% in some countries, and in Canada, it is strictly prohibited because its exposure may cause skin irritation, stomach infection, headache, liver damage, or even cancer due to its continuous exposure. We found that there is a lack of techniques in the literature for its detection. Some techniques are available, but with some drawbacks like requirement of derivatization. These are costly, require some sophisticated instruments, so we cannot afford them. So in this study, we have designed an LMR and LSPR based optical fiber sensor for the detection of DEA with two probes. We have prepared two probes. One of them is coated with the TiO2, and another is gold nanoparticles on the already prepared TiO2 coated probe. So for this, we have synthesized uh, two probes, TiO2 coated and biosynthesized gold nanoparticles on the TiO2 coated probe. So these are some steps that we have used for the preparation of TiO2 layer on the optical fiber. These are some simple steps that we have used there, and this image is showing here. This image is showing the coated optical fiber with TiO2. And now these are the biosynthesized gold nanoparticles, which are prepared with the belenite aegyptica fruit that was collected from the Suraj campus. And these are the fruit extract was prepared from them. And then these steps are followed. Tetrachloroauric acid was mixed into it, stirred at a particular RPM for a particular time, then centrifuged. And this step was repeated 3 times. And finally, the color of the gold salt was converted into the dark brown, from light yellowish to dark brown, which shows the conversion of gold salt to gold nanoparticles due to change in its oxidation state. So in this way, we have prepared the gold nanoparticles, and then the gold nanoparticles were deposited over the TiO2 bulk layer. These are the FESEM images, which shows the presence of TiO2 bulk layer and the gold nanoparticles on the TiO2 bulk layer. This is HR10 image of gold nanoparticles, which is showing the size of gold nanoparticles ranges from approximately 24 to 39 nanometer, and these are mixed shape nanoparticles like irregular, spherical, cylindrical, not cylindrical, spherical, diamond, triangular, or oval shaped nanoparticles. For the confirmation of these nanoparticles, a UV visible spectra was also obtained, and it is showing, we can see it is showing a peak at 541 nanometer, which is absent in case of gold salt. This red curve is showing the gold salt, and there is no peak in this for the gold salt. So this is confirming that it is these are the gold nanoparticles. So then we have prepared And then we have prepared 5 samples, different samples with the different concentrations varying from 50 millimolar to 800 millimolar. And these are the refractive indices that we have measured using a refractometer, Abbes refractometer that was available in our lab. And this is the curve, calibration curve, which is showing the change in refractive index with the change in concentration. How much change is there in the sample with the change in concentration. And this is the experimental setup that we have used for collecting data. This is our incident light source, which is used tungsten halogen lamp, and this is the spectrometer. This is the main part which is zoomed here. This is showing that here TiO2 and the gold nanoparticles are deposited over here. And when light incident from one end of the optical fiber, and the sensing process is processed here, then after transmission, the light is collected by the detector connected at the other end of the optical fiber. And this spectrometer is interfaced with the computer, where we can record our data and observe our data. And these are the transmission spectra of DEA with the TiO2 and the TiO2 gold nanoparticle coated probes. Here, figure A and B are showing the transmission spectra for the DEA sensing with the TiO2 and the gold nanoparticles over the TiO2 layer. And figure C and D are showing the calibration curve, showing the change in resonance wavelength with the change in concentration for both the probes, C and D. And these are the tables which are showing the same results. Here we can see the sensitive by using the gold nanoparticles or the TiO2 layer, the sensitivity is enhanced approximately 2 times, and the limit of detection is approximately 2 times enhanced. Now this graph is showing the time resonance and the stability plot. In this in this graph, what we have done is we have repeated the same experiment multiple times, approximately 5 times, and then we have recorded the time of stabilization and the response time. Response time is the time when we insert the liquid or the material or the analyte that we want to detect, when we insert that in the flow cell, and in how much time it gives response, which is response time. And stabilization time is the time taken by the probe to get stabilized after taking out the analyte from that quartz flow cell. So these are the response time which are shown here, and it is approximately 4 to 7 seconds, the response time, and the stabilization time is approximately 15 to 21 seconds. So this is, and here we have also observed that the resonance wavelength or the minimum transmitted intensity, the change in resonance wavelength and transmitted intensity is almost negligible, which is showing the stability of the sensing probe. Here now we are here with the a sensitive sensing probe. Now we want to make it selective towards amine only. So what we have done is, here this is the substrate. Substrate is here optical fiber, and this is TiO2 layer, and the gold nanoparticles are deposited over here. We have deposited another layer of carboxylic acid over the already prepared gold nanoparticle and TiO2 bulk layer. And when the amine come in contact with the carboxylic acid, it forms amide, which have higher refractive index than the amine, which is responsible for the larger shift in the resonance wavelength that we actually want. So here, this is the transmission spectra, which is shown. Here what we have done is we have now 2 probes. One is coated with the TiO2 and gold nanoparticle, and another is TiO2 gold nanoparticle, and another layer, additional layer of carboxylic acid. So here we are with the 2 probes. What we have done is, with both the probes, we have observed data. We have observed the transmission spectra for different analytes: methanol, toluene, glucose, and DE. We have taken 4 different analytes and then observed data. And we can see here from these graphs, these pink curves are showing for methanol and methanol plus carboxylic acid. These blue curves are showing toluene and toluene plus carboxylic acid. These red and green are showing glucose and DEA, diethanol amine. This is the bar graph, which is showing the higher shift corresponding to DEA only, which is due to the reaction of carboxylic acid with amine, which forms amide, which have higher refractive index than amine. So this larger shift is corresponding to the change in or the enhancement in the refractive index. So due to that change in refractive index or becoming the increase in refractive index, this redshift is obtained in the wavelength. So this is the reason of, or this is the basic concept or principle of making this sensor selective towards amine only. This will sense mainly amine only. And these are the conclusion for the study, that in this study we have synthesized the cost-effective biosynthesized gold nanoparticles, and we obtained a highly sensitive sensor for the with the help of these gold, biosynthesized gold nanoparticles, and the sensitivity is approximately twice than the only TiOT coated bulk layer. And the time response and stability of the sensor is examined by repeating the experiment multiple times. And the sensor is made selective towards DEA only using an additional layer of carboxylic acid. And according to us, this was the first attempt that an LMR based optical fiber is developed for the DEA sensing. There's lack of literature. And these are some of the references. And this is our laser and biosensing bioimaging lab in Sense IIT Delhi. Here we are working. And thank you so much. I think that's all from my side. I'm open to the questions.
So I will, you have quickly, you have finished.
Yes,
So
we can discuss now.
yeah, I think anyone is having the question, they can ask
Sure.
from the audience. Anyone is having the any question, you can ask. So in Sense Lab, you are having the fabrication facility also.
Yes, ma'am. We have here the fabrication facilities. In fact, we also have here NIL, the nano imprinting lithography, which is very useful to fabricate the nanoparticles over the substrate in a particular or a uniform pattern. So we are also going to use that also. It is currently just installed here in this lab. So we are going to use this in future. This will be very useful.
So like in Indian Institute of Science, there is a Sense Lab where we have the clean room, and in the clean room we are fabricating and we are doing other things. So like this, do you have?
Yes, ma'am. We have here the clean room, or the, because we have installed here the NIL, which requires a clean room. So we have here in our lab, or this department, since I did.
So we can able
We
to
have,
do the photonic crystal fabrication also in the range of the uh, we are doing the micron level. Micron
at micro
fab-
level. Of course, ma'am.
yeah.
Of course, we can. You can.
Oh, then it's really good.
Yes,
Okay. So I will inform my principal to join now. He was telling,
sure.
okay, so you keep that photo, your team photo is very good.
Yeah. Oh,
Yeah, your previous slide. Yeah, this is
yes,
your
yes,
team.
yes,
Usually
sir.
people are not remembering the team. Many speakers are talking and they are giving the talk, but you are the first one who remember the team. This is really a great thing.
Yes, ma'am. We are working here together, so that's why.
Okay. So you have the refractometer also?
Uh, yes, ma'am. We have the refractometer. Yes, where that we can use for the measurement of refractive index.
Okay.
And
In
actually, we
this
are also planning
in
to.
your talk the
Yes.
photo of refractometer is there?
No, ma'am, it is not there, but I can. This might be in my laptop, but not in this presentation.
In this talk in this presentation it
It
is
is
not
not.
there.
Yeah, yeah, yeah.
Okay.
I just forgot to
Okay.
show that.
So just a minute, I will call. Huh?
Yes.
Till then, any audience they can ask the question.
The feedback link for today's afternoon session is put in the chat box. Participants, please fill the feedback and submit.
I hope you got the idea what I have discussed here today. I think it is clear to you. If anybody have any query, then uh, you can ask me. Feel free to ask. Am I audible?
Actually, sir was expecting. He thought that 2 o'clock it started. So usually time is 1 hour. So he thought 1 hour he will join it over in half an hour. That's why I think he is not available. No issue. Okay.
It's
So
okay. We can talk at
some
some other
one
time.
question came from biotechnology. Uh,
Yes.
what is the name of the refractometer and how much it cost?
Actually, it's Abbes refractometer and its accuracy is
Can
up
you
to
write
4
in the
decimal point.
chat box? Can you write in the
Okay,
chat
sure, sure.
box so that I will inform him?
Yes, yes, sure, ma'am. Um, Abbes refractometer.
And it can able to this refractometer can be able to detect sugar or level in
Sure.
blood sample, urine urine sample, or what type of refractometer it is?
Yes, yes, ma'am. This refractometer will be able to measure the refractive index of the of the sample that may contain that must be
Your
liquid
voice is
only. So it will.
little louder, please.
Hello, is it audible now?
Yeah.
Yes, ma'am. I was saying that this refractometer have the capability to measure the refractive index up to 4 decimal places, and it cost 35,000. And uh,
So
it is
this
able to.
refractometer, this refractometer, urine sample also we can put.
Sure, sure, ma'am.
So in
The
you,
sample must be in liquid form. That can be that can be any material or any analyte. A
so my
urine
question
sample, blood
is,
sample.
yes, yes. I have one doubt actually. My question is,
Yes,
in urine sample, if sugar concentration we are targeting, but in urine sample, some other diseases sample is also there. So how refractometer will understand I am
Yes.
looking for sugar concentration in urine sample.
Actually, ma'am, it will show the different values of refractive indices. If we are here with the two different samples having some if we are measuring the glucose level in blood or some other chemical or some other enzyme in the blood, then we have to take two different samples and we will measure the refractive index of both the samples. It will show different values for both two. So according to change in refractive index, uh, we can analyze that what bacteria or what virus or what chemical is this present in the blood.
So
So
in,
we have,
if it is two refractive index in the sample, so it can be observed two refractive index, correct?
yes, yes.
Two
We have
refractive
to measure
index
two
can be
refractive indexes.
okay. So in the
Because
sample, if
first we will take the pure blood and then the another sample will be glucose in the blood. So we are here with the two values of refractive indices. One is for the pure blood and another is for glucose in the blood. We will take the difference of two refractive indices. Then we will analyze that this change will correspond to the glucose or what chemical. This changes according to the chemicals or the refractive index values will be changing according to the different chemicals.
okay,
There
okay.
might be
So
some
in
other methods, a pH meter or something to measure
okay,
them.
okay. So our biotech department people, they are very much interested to take the sample refractive
Yeah.
index, because once we will take actual refractive index value and something is from literature survey, these two are different. So when we are measuring an actual, we are getting RI value, then it is more effective. Yeah. So you post in the chat box and
Yes.
we will take. You post in the chat box
Yes.
name of that.
I have written here in the chat box. Average refractometer cost is 35,000, and accuracy is up to 4 decimal places. So it is very accurate, very precise.
Okay. So I have.
This is very good refractometer. Actually, I don't remember the name. Uh, I told you before. Actually, I will send you after some time. Actually, if it is
Yeah.
needed, the model, the name of the model of the refractometer. If you precisely want to know,
Hmm.
the accuracy is up to 4 decimal places, and
Okay. So from my side, this question. And the second question is what work you have done in SPR or LDR? You have tried for fabrication?
for fabrication. Sorry, ma'am, I didn't get.
Fabrication you have tried?
Fabrication process, of course, yes, we have done the fabrication process, the fabrication of gold synthesized nanoparticles. We have prepared the or deposited the prepared TiO2 layer and the gold nanoparticle on the optical fiber. Then we have used this probe in the experimental setup that I have shown you before, and then observed the data. So this was all the fabrication and designing process. And of course, we have done the simulation also for this. Simulation work is also done in the MATLAB.
Oh, okay. Okay. Thank you. Thank you from my side. So anyone is having any question? If they are in the domain of photonics, they can ask the question. Otherwise, it is not relevant because here people are from all the different department. Okay. If not, then I will tell uh, uh, organizer in formal way end the session. And last question is actually I am in WhatsApp. I am getting Kavita. Last question is from where we should buy this. Uh,
Okay, so there are so many companies here in India, which Sigma Eldridge or Alpha Acer. or
Can you write in
thermo.
the chat so that I can, those who are asking me in WhatsApp separately, I can send them. Can you write in the chat?
Okay, sure. The sigma Eldridge, sigma Eldridge. Alpha is. These are good companies which provide this, and also Thermo Fisher.
So these two are from the online we can get.
Yes, ma'am, you can contact to the vendors also, which are available in all over the India. And
Okay.
yes, of course, you can order online. You have to contact the company. That's why we have collected all the order through the channel actually. We have contacted the vendor and made the purchase order. Then
Okay. Now I
Ma'am,
think, yeah.
uh, thank you, Kavitha ma'am, for your valuable insight on biosynthesized gold nanoparticle enabled fiber optic sensor for selective diethanol amine sensing. Thank you, ma'am, for your valuable insight. It has helped a lot of people knowing the architecture, everything, sensor, internal working and all. Thank you. Thank you once again.
thank you so much for inviting me. Thanks.
Thank you.
So should I leave?
Thank you, Kavitha. Okay.
Thank you.
Participants, I'm reminding once again, the feedback link is already posted in the chat. Please fill the feedback form and submit.